And in this video, we understand the topic deadlock in an operating system. Let's start. Understanding a deadlock. In this video, we understand a comprehensive overview of deadlock. We will discuss concurrent systems, resource management. Deadlock occurs when processes block each other indefinitely. We will explore strategies to prevent, avoid, detect, and recover from deadlock. The goal is to improve system reliability. What is deadlock? Definition and example. Deadlock is when two or more processes are blocked, they are waiting for each other to release resources. Let's example we have two trains on a single track, two people needing two resources each. Consider two trains approaching each other on a single track, neither can proceed. Now we understand characteristics of deadlock. If these four conditions occurred, then deadlock happen in our process. Four conditions are mutual exclusion, hold and wait, no preemption, and circular wait. Exclusion. Resources are non-shareable. Only one process can use a resource at a time. Second, hold and wait. A process holds allocated resources. It waits for additional resources. Third, no preemption. Resources cannot be forcibly taken away. Process must release them voluntarily. Fourth, we have circular wait. The cycle of processes exists. Each wait for resources held by the next process. Next, we have visualizing deadlock resource allocation graph, in which we have nodes, edges, and cycle. Nodes represent processes and resource. Process are circles, resource are square. Now edges represent resource request and allocation. Point from process to resource. Allocation edges point from resource to process. Now cycle. A cycle in rag indicates potential for deadlock. This shows circular dependency. Now we have the methods in which we prevent deadlock prevention in our process. If we avoid any one condition of the Kaufman condition, we can stop the deadlock in our process. First, we have already studied mutual exclusion. Difficult to eliminate, some resources are intrinsically non-servable. Hold and wait. Process request all resources before execution. This can lead to low resource utilization. No preemption. If resources is not immediately available, receives held resources. Circular wait. Impose a total ordering of resource type. Require process to request in increasing order. Now deadlock avoidance. How we avoid the deadlock in a process? We can use so algorithm, but we use there two algorithm: save state and bankers algorithm. In save state algorithm, system can allocate records or it can avoid a deadlock, in which a resource used by one process cannot be used by another process in the same time. In this way, we can divide the resources not simultaneously but in an appropriate manner. Now we have bankers algorithm. In bankers algorithm, we use advanced knowledge of resource need, how to manage it between two process so that no deadlock happen in a system. Third, we have track resources. In track resources, we track available, allocated, maximum, and remaining needs of resources between the process in the system. Next, we have grant request. In grant request, only if it is result in a safe state, we can give the resources to the process if it is in a safe state. Otherwise, we not provide the resources to a process. Now, how we can identify the detection, identifying an existing deadlock in a process. We can use the detection algorithm, periodically checks for cycles in a reg. Second, we can use algorithm depth for search to find cycles of loops in which the resources are used by the two processes simultaneously, which led to the deadlock. Next, we have invocation frequency. In invocation frequency, we can use trade-off between detection overhead and duration. Now, deadlock recovery, resolving detected deadlocks. These are the methods through which we can prevent deadlock in our system. Process termination. Avoid process to break the cycle. We can terminate the process to avoid the directly the deadlock in our system. Resource preemption, take resources away from resource processes simultaneously. If this problem happening to or more process taking the resource simultaneously, take resources from the processes. Now rollback, return process to a save state and restart. These are the methods through which we can prevent deadlock recovery. Now come to the conclusion. We how we balance prevention, avoidance, and attacks. We study all these, how we prevent, balancing the deadlock. Deadlock is involve intricate trade-offs, consider cost, resource use, system complexity. Real system use a combination of approaches. Understanding deadlock is a key for system reliability. I hope you understand the deadlock. Thank you for watching the video.